Hello everyone, welcome to Fractions Up. So today I am here to discuss a problem in geometry. So I'll introduce the problem first. So here is the problem. So we have chords AC and BD of a circle omega which intersect at P, as you can see in the figure, and a smaller circle omega 1 is tangent to omega at the point E, and two segments AP and DP at E and F. So what we have to prove here is that a TE bisects the arc ABC of omega. So you can take a few moments to look at this picture. So here's the bigger circle, the smaller one, and we have these two tangents to the smaller circle, which are also the segments chords of the bigger circle, and we have to prove that this ABC arc is bisected by this ray TE. So first of all, let us take a look at what will be the construction that we have to do for this problem. So in here, as you can see, I have extended the ray TE to meet the circle omega at this point M, and I have drawn this line XY tangent to this both of the circles at the point T. So now our agenda is to prove that this ray TE bisects the arc ABC. So that will be done if we could prove AM equals CM. And in turn, this will be proved if we could show that this angle ATM is same as this angle CTM, as all these points M, C and T lie on this bigger circle. If we have this angle inequality, of course this inequality will follow and vice versa. So if we show this inequality here, then would have solved the problem. So for that, let us now do some angle chasing on this figure. So we have xy, which is tangent at the point T, and we have chord AT. So the consequence of this would be this angle ATY would equal this angle ACT. So I would mark this for convenience. So this angle right here, this is equal to this angle here. And again, so further, notice that now we look at the smaller circle. AC is tangent at this point E, and XY, as we said before, is tangent at this point T. This has the consequence that this angle, I'll mark this angle first. So if you look at this angle AET, this would equal the angle ETY. So let us write that down. So angle AET equals the angle ETY. So these are the equalities I have, and my aim was to show these two angles are equal. That is, this angle ATM would equal this angle CTM. So let us see if we have that. All right. So I have these equalities of angles that I already have from the previous page. So now I write down this angle ATM, which is the same as angle ATE, which would be the bigger angle, angle ETY minus the angle ATY. Now we apply the equalities we already have. So this angle ETY, as we discussed, this is same as the angle AET. So we replace that. And again this angle ATY, as we discussed, this is same as the angle ACT. So we again replace that. Now look at this outer angle here, which is the angle AET, right? So that would be this angle. Note that this is the sum of the angles, angle ACT and angle CTM, also CTE. If we look at this triangle, triangle ECT. So the equation we have written here, this is exactly equal to angle ECT, which is sorry, this is equal to this angle MTC. So now we have angle ATM is equal to angle MTC, which is the angle CTM. So we have the equality which we wanted, and now this problem is solved. So thank you for listening to this, and for further interesting problems on various topics, do visit our website www.fractionshub.com. Thank you.